Hey guys, what is up? Quackor here. Welcome to the sixth tutorial in our Big Data in the Cloud with Hadoop and HBase series. As you probably saw in our previous tutorial, which was pretty long, we wrote our bulk upload MapReduce script and we ran the built-in loader to load that data into HBase. So as you can see, I still have the output up on my screen here. These are the various HBase tables that now we can write we can either do things like query each of these fields directly, use it as like a normal, database, kind of like SQL or some other NoSQL database. Or we can run MapReduce jobs on top of this, or Spark jobs, or whatever other technology we want to use to get like some really cool, analytics data off of this like large data set. Now remember, we only imported one CSV file out of the 12 different CSV files. So if you could imagine, this amount of data times 12, maybe even times 24 if you want to include the other CSV file that we have. That's a lot of data, so we might not want to actually query everything we want directly through the HBase, but we want to actually run MapReduce jobs on all the data and kind of collect some aggregated data out of that. So that's really where HBase shines, is storing tons and tons of data and then being able to either access sparse amounts of it randomly or be able to run like complicated aggregated jobs on top of it. So we're going to go ahead and write one of those aggregated jobs. So as you can see, I have pretty much the same structure as the bulk upload script in the previous tutorial with the Java, Java structure, except I just have a MapReduce instead of bulk. And this POM XML file is pretty much exactly the same, just with a few things changed here and there. So you can pretty much copy and paste. Again, this will be available on my GitHub, so if you really want, you don't have to write any code at all. Okay, so for this MapReduce job, we're going to again need our driver class, and then we're going to need our mapper class, and we're going to need a reducer class. So it's going to be a little bit more complicated than the previous one. But I'll make sure and walk you through it as best to my knowledge, because again, this is a learning experience for both of us. So let's go ahead and get started. Let's create our job class, which will be pretty much just be our driver. So let's just do public class fair job. Again, we just have to write a little bit of boilerplate code. So this is pretty similar to our driver class that we have here. We're just going to be reading in, a path, and then we're going to be feeding it into our MapReduce script. Okay, and I'm just going to copy over some imports from the last one. Again, this is just for brevity's sake. So we actually need to pass in the table name as the first argument. Again, we could always hard code it, but if we ever want to change table names, this is a pretty good idea. So just do string table name equals arg0. Again, we're going to create our configuration like we did with the previous MapReduce script. So a lot of this will be kind of repeated information. And set the table name. And remember, we have to create a job. Job equals new job, pass in the configuration, taxi, let's just do fair job since we'll be aggregating off of the fair table and we're going to be aggregating the actual fair value. So we have to set the jar of our mapper. Last one was like HBase mapper. Let's just go ahead and call this fair mapper. And let's go ahead and create that file right now. Cool. Exit out this stuff. So this is our mapper class that'll be taking in the input data, which remember from before was a CSV file. In this case, it's going to be an HBase read, which actually an HBase scan, which we'll be setting up right now. So we create our new scan. Caching is just how much data it holds at any one time. So this is just configurations I've read myself and I've used. They seem to work pretty well. You can set your own configurations if you want. Okay, so the important thing is we need to add the column that we are going to scan on. Remember, everything with HBase is stored as bytes, so we have to do a byte conversion. And we have our D column family. And then we want the actual column value that we want to scan. And this should actually be add column. So add column, column family, and then the actual column name. And we want fair. And we actually want a medallion as well. So you can probably guess how that's going to go. Pretty much the exact same. And we're going to use this table MapReduce util class to basically init the mapper job. So what's I guess pretty much what's going to happen is once this mapper executes, it's going to read from HBase. It's going to use the medallion ID as kind of a bucket. So everything with the same medallion is going to be mapped to the same bucket where we're going to be accumulating the fair values of each of the medallions. So for instance, if a single medallion, like say this one, has a value of 8 as one of its fair, and the same medallion, which I believe these are, has a value of 21, we're going to be bucketing both of these medallions together, and we're going to be combining the fairs together, so when it gets passed to the reducer, like when it gets passed as in the medallion and the combination of 8 and 21 gets passed to the reducer, we can reduce it down to one value, which is going to be 29. So mapping you can think of as kind of bucketing a collection of items into one key, multiple values, and then reducing is taking those values and doing something with them. In this case, we'll be combining them, and then we'll probably be writing them back into HBase. Or we can do things like print them out just to see like what is the medallion with the largest fair, or just print medallion and then the combination fairs of each of those. Okay, so let's do a init table mapper job. Just make sure we got everything spelled right so we don't have to go back and change very much. Table name. And we have to do the scan. Again, the mapper class. This is going to be what the mapper is outputting as its key, and what it's going to be outputting as its value, and then the job. So the key text, so that is the medallion. And then remember what we are actually outputting, what will be collected together is the fair, and the fair is most likely a double, so we're going to be using double writable. And we also have to do the same thing with our reducer task. So table map reduce util init table reducer job, table name, pass in fair reducer. So let's go ahead and create that one as well. Fair reducer.java. So this is our mapping class and our reducing class. And we won't have any outputs for reducer. We are either going to print or just write directly into HBase. We're not going to be feeding it into anything else, so we don't need to specify, outputs as we did here. And then we pass in the job. And job, we have one reduce task, so set num reduce tasks 1, and then again job wait for completion. Okay, so everything looks pretty good here. So that is, again, our driver class, pretty simple, nothing too complicated. And let's go ahead and go to our mapper. So again, I'm going to copy in some import statements. So the fair mapper has to extend a class known as table mapper. And remember, text double writable are outputs. Table mapper because we are reading from an HBase table. So let's see, HBase MapReduce table mapper. So that's that class name there. And we are just going to override the map, similar to, let's see if we can bring up this HBase mapper. So in this one, we extended a normal mapper because we aren't actually doing any specific HBase table specific things. We're just doing a normal MapReduce job. And in this case, we have to extend table mapper because it's HBase. So again, we have to do protected void map, bytes writable key, result, value, context. So pretty similar to our previous one. exception. Cool. Okay, so we are passed in the row key of the HBase row, and we are passed in basically a result, which is a single row, and we are passed in the context. So the results you can think of as, remember in the previous one we had the result was actually a single line of the CSV file. In this case, the result is a single HBase row. So you could actually write a job that reads the CSV files and does exactly what we're doing here, which is going to be aggregating them together and like producing some accumulated fair value. You could do that directly from the CSV files, but that's probably going to be a lot slower, and it isn't really practical if you want to keep reusing the data that you have stored in HBase, which is why we stored it in HBase to begin with. We want to have some sort of persistence. And because we enabled HBase backups on our server when we created it, so that data is going to be stored in S3, so if we ever want to like load this up again and play around with it more, it's already set up for us. Like all that data in HBase is going to stay there. We don't have to re-download the CSV files or re-copy them over from S3. It's going to be it's all good. It's all set up. Okay, so let's go ahead and grab the medallion and the fair values from HBase. So remember, everything's stored as bytes. So we'll do medallion bytes equals value, which is, remember, that is a single row. So we have to do value.getValue. And we have to specify the column family, which is just bytes, 2 bytes, D. And we have to specify the column name, which is medallion, or M for short. And we do the same thing for fair. Fair bytes, D, and then this one is F. And let's go ahead and convert them to nice values, because we don't really want to deal with bytes. Double, so bytes to double. Okay. And let's go ahead and create, since we want to output a text and double writable as our output, we need to create a text object. So let's just create a global one so we don't have to recreate it. Recreate it every single time this map is called, because that would probably, I don't know if it would run out of memory or anything like that, but it makes more sense to have it as a global variable. So let's set the medallion, and then we don't actually have to do, we could do the same thing with double writable, but let's just create it on the fly. So again, our output, which we are writing, is text, which is the medallion. Remember, this is what we set up here, text double writable, as our two outputs. And then we create a new double writable, and we pass in the fair value. Cool, so that's all we need to do. So all the mapper is doing is it's taking, reading from HBase, kind of combining it into this text bucket, and it's combining the actual values. It's not combining them together, but it's mapping them, it's mapping them to a single text value. So you can kind of get the whole idea behind MapReduce based off what we're doing here. So I believe that's all good for this one. So now we can move on to our reducer class. Again, I'm just going to copy in some imports. So this one will be a little bit new since we didn't actually write a reducer class for our bulk upload script. We specify our inputs, double writable, and immutable bytes writable. Double writable. Just want to make sure everything's spelled correctly. And we are overriding instead of a map, we're overriding a reduce. And our inputs are text key. And we're doing an iterable, double writable. Remember how I said multiple values would be mapped to the same key? In this case, the multiple values are stored in iterable. And our context. Make sure to throw our exceptions, which hopefully will never happen. Cool. Okay, now we need to actually do the reducing. This is where we combine the multiple values. We can do whatever we want with these multiple values that are mapped to a single key. In this case, we want to sum them together. So let's do our simple reducer task. For each of the values, we want to combine them. Let's see, bracket, bracket, bracket. So that's all we're doing. That's all our pretty much all our reduce task is doing, is just combining them together. And then we can just do a simple print line, sum for medallion, key is sum. And let's go ahead and write this back out into HBase. Just so if we ever want to, query, like, get all the sums for a single medallion or get all the sums for all the medallion when it's written out into HBase, we don't have to actually write this MapReduce job again or run it or anything. We can just query it directly from HBase. So it's just like storing it back into like a persistent data store. So let's create our puts, our HBase put. Okay, put key, and then we want to add our aggregated column family, which is going to be, I believe I said it was A. So this is where we are writing to. And we need to create our column name. And let's see, and the actual value itself. Okay, so we created a put with our row key is actually the medallion. Notice in our previous one, our row key was the medallion and the drop-off time, but it doesn't really make sense for the aggregated to have the drop-off time because all we care about is aggregated statistics for a single medallion, which is why our row key is just the medallion instead of a more complicated combination of medallion and pickup date time. And then we added to the column family aggregated, which we created that column family in one of the previous tutorials through HBase shell, and we're storing it in the sum column name, and we're storing the sum value. And that's it. All we have to do is just do context.write, and we write the put. So if we take a look at HBase, okay, just mapper. Cool, everything looks good. So let's go ahead and copy this over and compile it, and I'll get back to you once I've done that, since we don't want to repeat that again. Okay, we are back. I went ahead and zipped up this source code and copied it into S3, and we're just going to copy it back out into our server here. Let's go ahead and unzip it, cd into MapReduce, and cross our fingers and see if I wrote everything correctly. So it's compiling. Didn't have to download any of the dependencies because we had already downloaded them for the bulk upload script. And wow, looks like it worked. Cool. So we can go into target, see our jar file there. Cool, everything looks good. And the last thing we need to do is run the job. So we can do that the same way we ran our bulk upload job. We'll just hadoop jar, New York City taxi, MapReduce jar. Again, we have to specify our driver class file. Quackware, New York City taxi data, MapReduce.fare, and what did I call it? Fare job. And I believe I passed in the table name as well. So let's go ahead and run that. So class not found. It's probably misspelled something. Let's take a look. com.quackware.New York City. Yep, New York City taxi, not New York City taxi data. Let's run it again. Looks like it's loading everything up. Looking good. Job is now running. Not sure if it'll take quite as long as the previous MapReduce job, but we're going to go ahead and pause it and let this run out. Okay, and it looks like our MapReduce job failed due to some error. You can see line 31. So I guess it isn't playing nicely with double. I think I ran into this error before, and I believe by just changing this to bytes to string and then converting it to a double later, it'll actually fix it. I'm not entirely sure why this is occurring. Maybe someone can help me out in the comments after this is done. but let's go ahead and recompile this, which I believe, yeah, I already did before this, and let's rerun it and see if it works this time. Target. Still, you know, I'm a newbie at Hadoop and HBase and this stuff too, so yep, a few errors will occur every once in a while. Alright, looks like the job is running. We'll wait a little bit longer before I pause just to make sure it's working correctly. Let's see if this increments at all. So that's one complaint often by MapReduce jobs. They're a little bit slow every once in a while. Cool, looks like it's actually working now. So we'll go ahead and pause this and wait till it's done executing. We'll bring you right back. Okay, it looks like our HBase MapReduce job ran successfully. So cool. Let's go ahead and just see if the data is available to us. I'll just do a quick scan since I don't want to make this tutorial too long. There. Let's go ahead and cut that out. So we're looking for aggregated data. We actually want to do a scan on the A column family, or rather on the sum column with the A column family. So let's go ahead and bring that up. HBase shell again. Sorry for the cutout there. Just needed to figure out exactly what I was doing. So we do scan fair and we specify the columns. Do A, and then we want to do sum. Just see if we have the data available to us. Cool, look at all that data. So for each of these medallions, we have a sum, and looks like the values are stored, they're stored as bytes for the double. This is probably because we wrote these puts as a double rather than as a string. So if they're as a string, we'd actually be able to see the values here, but don't fear. These values are here. They're just stored as a byte array representing doubles. This is probably would have been more efficient than storing it as a string. But yeah, I'll leave it up to the watcher to basically create any sort of fun statistics out of here. But we've pretty much done most of what you guys need to know in terms of using HBase and Hadoop in the cloud. We set it up, we talked about it, set up our Amazon EMR, talked about configuring it. We took a look at our data set, tried to figure out some sort of HBase schema for it. Then we went ahead and configured our server, installed everything we needed to do, moved the data into HDFS, created our tables. We wrote our script which read in the CSV files, converted it to H files, and then ran the incremental loader to upload those H files into HBase. And then we went ahead and ran the MapReduce script that we wrote the MapReduce script that read from HBase, kind of aggregated those stats together based on medallion, and combined those pairs together and then wrote that back out into HBase. And that is the result here. And you can now, query on these medallion numbers to get, specific fair values. And when you combine all those other, 23 other CSV files, you can see we have really a wealth of data that you can query on once you kind of get this process set up. You can even automate pretty much this entire thing, but figured this would be kind of a good introductory tutorial for big data, kind of get you guys starting on whatever fun projects you have in mind. So I really appreciate you guys watching this entire mini-series. It was fun to create, a little frustrating at times trying to get things figured out, but that's pretty prevalent with any software development stuff. Let me know in the comments or through a message if you want to have any follow-up tutorials on this. I can spin up another instance and see if we can mess around with this data if you guys are really interested in it or getting the results. But I figured I'll leave it up to you guys to do that. And all this source code will be available on my GitHub, github.com/quackware. You can also access it through my website, curtismlarson.com. And yeah, make sure to comment, favorite this playlist, whatever you do on YouTube. I don't even know. But yeah, thanks for watching, guys. That's it for this mini-series, unless you guys want some more tutorials. But yeah, make sure to also watch all my other videos. This is Quackware signing out.